Alright, so let's talk about another sort. This is an interesting one, and it's called merge sort. So the way merge sort works is by repeatedly breaking your data set into parts, and then when you have the smallest little parts, bringing them back together. But like all of our sorts, it helps to have messy data, so let's start by shuffling it up. Okay. And we now have a messy set of data. Now on first glance, I take a look at this set and I think, gee, this is pretty intimidating. It's a little bit hard to think about how I'm going to organize these. So rather than worrying about sorting this big giant list, instead I'm going to break it into halves. So because I have 9 cards, I'm going to have one half that is 5 and one half that's 4. And now recursively, I'm going to apply the same thought process to what I have left. So, boy, 5 is a lot of cards. Let's split that into 2 halves. And 4 is a lot. Let's split that into 2 halves. I say, boy, 3 is a lot. Let's split that into 2 halves. And 2 is a lot. Let's split that into 2 halves. And eventually, I'm going to end up with all of these individual cards in their own individual place. And this is where the merging begins. So you can imagine this as a tree trunk breaking out into all these little branches with all these leaves at the end of the branches. At this point, I begin the merge process. Now, I have a stick here that breaks out into 2 branches. At the end of one is a 7, the end of the other is a 4. Now, all I have to do is compare these two when I bring them back together, and I'd say, well, 4 is less than 7, so I'm going to have the 4 go in first, and then the 7 after it. Now, recall that this would have been on a branch by itself, so the 6 comes down. The 8 and the 10, they get merged together. The 5 and the 9, they get merged together, and the 2 and the 3 get merged together. Now, these are on a branch, these are on a branch, and these two, well, it looks kind of like that. They're on a branch. So I'm going to start merging these together. But for all of my small data sets now, I'm guaranteed that in each particular list, the leftmost card is the smallest. So when I go to merge these together, all I have to do is look at the leftmost card in this first set. So 4 is less than 6, so that's going to go down first. Then I move over. 6 is less than 7, so that goes down second. 7 is alone, so that goes in. Now I have this set and this set on one branch of the tree, and these 2 sets on the other branch of the tree. Let's do this merge again. I'm guaranteed the leftmost card of each set is the smallest, so I check those 2 against each other. Since the 4 is smaller than 8, that's going to be the first thing in my new list when I merge them together. This index moves over. I see that the 6 is smaller, so I put the 6 down. Index moves over. I see the 7 is smaller, so that comes down. I see that now there's nothing left of this set, which means I can just bring this whole set down without even having to check them. So I have that branch done. And I still have these 2 sets over here. I check the smaller one. Well, 2 comes down first, then 3. There's nothing left in this set, so this one gets tagged on to the end. And now I'm ready to do my final merge. So every single time I've merged, I've taken 2 smaller sets and made them into a big one. This is the last series of those merges. And again, I start by looking at just the leftmost card of each set. This 2 is the smallest, so that comes down first. Then the 3 is smaller than the 4, so that comes down. 4 is smaller than a 5, so that comes down. 5 is smaller than a 6, so it comes down. 6 is smaller, so it comes down. 7 smaller, it comes down. 8 smaller, it comes down. 9 is smaller, it comes down. And then 10 left alone, so it comes down. Now, the merge sort might seem a little bit complex, like there's a lot going on, but coding-wise, it's actually relatively easy to code recursively. And that's because there's only a couple parts to it. The first part is the break apart. The second part is the reassemble. And when you think about it, the most base case, when you're just putting 2 cards together, it's pretty easy to do a comparison between 2 single cards and decide which one should come first in a new set. Now, if we just work our way back up, when we got to the point where we had, say, 2 big data sets, even though we had to put these 2 big sets together, we were still only ever making a decision about any 2 cards, the leftmost card in each set. So it was relatively easy to put them together because we were just doing that comparison, and then as we go, move whatever index needs to in the remaining sets that need to be merged. So that is merge sort. I hope that you found this helpful. Bye now.